No, haven't seen Doug today, so I'm not sure.
Yeah, Doug, I don't think is going to. I got a message from him.
Okay.
So might be pretty quick, but that's fine. Yeah, so the meeting this morning was super cool. We ended up having people from 6 different countries show up,
Yeah.
which is like pretty cool.
Yeah.
And so we just walked through like so you know how we put together like the EM notebooks repo on
Yeah.
for a lot of the disk stuff? We added 2 that invert the data over bupronon. So one frequency domain notebook and one time domain notebook, just that invert a single sounding.
Yeah.
And just like walked through that with everyone. And so yeah, it was really good. It was nice to get like questions, and I think this is a good format and something that we should think about like trying to do every couple of months is like put together, you know, like we'll talk about regularization or something like that, and you could do one on your like interesting use cases there of the regularization, Thibaut. Yeah, so I was pleased with that.
Nice. So you had. I just look at the YouTube video briefly, and I saw you had like Dikwan, Jaja, Alini, maybe also, or maybe not.
No, so there were 3 PhD/master students who are in Italy and in
Okay.
and so they were working on time domain EM inversions as well as actually magnetics. So we didn't touch magnetics at all, but like a lot of the same machinery, of course, is used.
Nice.
Yeah, so that was pretty cool. So, and then we've asked that like they jump in and actually annotate the notebook and like put more notes in it and contribute that back. Yeah, so I think that like they seem quite keen to do that, and I think that's a really cool way to start like doing tutorials like this. Is like we put together as much as is feasible for us, but then actually ask that other people, like based on what they learned, then fill it in for somebody else.
Okay.
Yeah, so I think that's a cool way to onboard people and to like break the workload a bit.
And it's recorded, so it's easy to go back and.
Absolutely, yeah. Yeah, cool. All right, so I have the meeting notes up. Do you guys have those as well?
Yeah, I've missed that. Did you make some? I've missed them.
Yeah, I sent them through on the meetings channel on Slack, but I can also just share my screen. I think that's totally fine.
Oh, I can open them here too. That's. Yeah, I don't know. Yeah, okay.
You got it. Okay.
Yeah. Actually, that's the same link. So wait a second. I'm gonna break everything. Okay. No. So it's just twice the Hangout link. So yeah, no, I don't have access to the notes.
Oh, sorry. I screwed that up. I'll send it through again.
But just put it up screen share on your screen. That's fine.
Yeah, sure. I changed it in Slack, so if you do want
it. Yeah, just so.
So can you see that?
Yeah.
Cool. Okay, so I don't actually have like too many items, and feel free to jump in if there's other things that you both would like to go over. Yeah, so regrouping on the EM tutorial. If you have a chance to watch it, or you're curious to watch it and have any feedback based on what we did, like I would love to hear that and capture it.
I might take a look at some point. Yeah.
Yeah. Cool. Okay, and then I wanted to show, I think the docs for Discretize are like, I'm quite happy with this iteration of them. I think that like it still needs some more work, but I feel like it's sort of good enough to potentially merge, and then we can iterate from there.
Okay.
So I'll generate a pull request this afternoon, and we can chat through it and like iterate a little bit in the pull request before we merge it. But we talked a bit about this last time, so having it broken up into like headings is like getting started, then a bit of a user guide, and then the API documentation. And then
Okay.
I've also added some external links. So this is like completely adapted from a lot of the work that Leo has done in Fadiendo. He's written beautiful docs, and they are open source, and so we are adapting them. So if we look, the user guide ideally will be all Python scripts that are compiled to RST. So like then when you look at the end of this, you can download the source code or you can download it as a notebook. So this is actually where I see the biggest need for development, both with respect to like setting up tensor meshes. And then Dieter's been asking a lot of questions just on like finite volume and how do the differential operators work, how do inner products work. So I think we need to actually like beef up our user documentation on a lot of that. And I think, I mean, even for us, like going through that again would be very valuable. So once, like what I would like to do in conjunction with the pull request is then actually start an issue where we outline like what are some of the user guides that are really high priority for Discretize. The API reference took a bit to like get into better shape, and there's still a few bugs, like we need to add docs to these guys, for example. But if we look now at the SIL mesh, the way I've tried to break this up is so we go by class. It'll tell you everything that it's inherited from. This is the documentation on the class. So let me just pull up this so that you can see where it's pulling from. So like this text here is just on the class documentation, if that makes sense. Do you see where that's coming from? Okay, cool. And then added some plots. I think what we should try to do is with every single class, we should make sure that we've got a minimal example and a plot of something, just so that it's a little more clear what it is and why you would use it. So this one has a cylindrically symmetric mesh and a 3D SIL mesh example of just like how to generate it. And then we go through and document all of, well, then there's examples. So this I quite like having sort of upfront is if there's other examples we have that use it, those are now automatically linked. So I didn't have to do any extra work to get these to show up here, which is cool. And then we document, of course, all of the attributes and then all of the methods. So these are now all using the NumPy style documentation. So if we look here, it takes up a little bit more vertical space, but it gets rid of that, like this strange Sphinx documentation style where like you have the colon param colon whatever, which is just like hard to read, especially in the notebook. So yeah, this is like much friendlier in plain text. And when you pull it up in the notebook, I think it's much better. So yeah, do you guys have any questions with that, or like?
I have an unrelated question. I see that when you're in Sublime, you see who wrote which line of code, which is pretty cool. I didn't know you can do that.
I think that's the Git gutter, potentially.
Okay.
Is the project plugin? I can look afterwards if you're curious to get that. It is.
I can. Yeah, I don't know if I want it, but it's just like yeah, it's a feature I didn't know about.
Yeah, because it actually like gives me the text from the commit, which is kind of cool.
Yeah.
And it's also nice to see like when something has changed more recently versus like this was 4 years ago. So I don't know, it's kind of cool.
Nice. No, that's a lot of work. Like, thanks for that, Lindsay. I see that in the user guide we don't have the I guess the octave mesh gonna be the one that's gonna require a lot of work afterward.
Yeah, and the cylindrical mesh is just a placeholder right now. So I think like what I was sort of thinking is we should have one for setting up each of the different mesh types. So this like overview gives a bit of an overview of just what each of the things are, where things live, all of that sort of stuff. then we should have something that constructs and walks through each of the mesh types. We should probably have something on like I/O, so reading in UBC meshes.
Yeah.
Can somebody maybe write these down? Is that
Mike, do you see the link on the Slack for the?
Yeah, let me go open Slack.
okay?
Yeah. Yeah. I think what we would really like. I like to. I think that we would need to have like to really like nail down the tensor mesh first, and then basically copy paste the. Like the structure of that for the cylindrical and the octree mesh to really see what we want in that user guide.
Yeah, agreed. I think that's a really good call, Thibaut. And we might end up having to make like multiple examples for each. Yeah, but as a first shot through, like let's give this a try. And I agree. Let's hit on the tensor mesh one, get that in like a shape that we're really happy with.
Yeah.
And then go from there. Yeah, so because then we'll need one for octree mesh, we'll need one for the curvy mesh. And then I think we should almost have one for each differential operator. Instead of like having it all lumped under finite volume. Because right now this is like nothing. It just this paper about finite volume, which fair enough. The one on inner products is actually pretty good. And this needs to be translated to the Python style script. Right now this is still an RST.
For the inner product, did you take? That's not from your leading edge paper for discretization of. Is it?
No, this was written beforehand. I mean, they should be consistent, hopefully.
Yeah.
But yes, this was written beforehand. So I didn't write any of this. This was already in the docs. Yeah.
So you want the different operators in the finite volume chapter, right?
Well, I think like what I could actually see happening is we've got a finite volume one that is perhaps just an overview of where things live. And then I think potentially afterwards, we've got one on the edge curl. We've got one on the cell gradient, one on the nodal gradient, like those kinds of things.
It might make the list of the user guide fairly big.
Yeah,
No?
well, we can always nest it if we need to.
Yeah.
Like it doesn't have to be top level, but I think that doing that might be easier than having like a ginormous finite volume.
Okay.
Page.
Yeah.
So we can try it and like iterate as it makes sense. But yeah,
Okay.
I think like if you're looking for the edge curl and we just have a short notebook that talks you through like what's going on, that might be easier to digest. Here's a treatise on finite volume. Cool. Any other thoughts or questions at this point?
I have to admit that I'm a bit confused about something too. Like it feels like in the user guide and the APIs there might be a lot of overlap. Because I do admit at some point I thought we were in the user guide for the cylindrical mesh, but then that was what you wrote in the API.
Yeah, so I think we should maybe write a small documentation guide, because I think when we get here, so for the tensor mesh, like this page is much more in depth than what the class documentation is. I think the class documentation, we should still strive to have like a minimal example and a plot wherever that makes sense. So
Yep.
like minimal example being, here are 4 lines of code that build a mesh, like nothing fancy, no bells and whistles, just like here's the bare bones of how to use this thing. Whereas once we get into the user guide, it's much more focused on, okay, like this is now how I try and use this to solve my problem.
Yeah.
Yeah. So I think that's a good call, Thibaut, is like a documentation guide for ourselves as to like what documentation should contain. Like NumPy's got a really good guide that we can sort of adapt from what makes sense for us. Cool. Okay. Are you good if we move on to the next item?
Yeah.
Okay, cool.
I'm sorry, I just don't find the time to review that PR.
No worries.
I saw Soggy beat me to it. That's
Yeah.
good.
So we took a look. I mean, if you would like to take like a quick, brief look after, because I iterated once based on his comments. So from my perspective, this is good to go.
Yeah, so go for it. Don't wait.
Okay. Yeah. So now what we have, we're adding like the surject units. So that was previously what Dom was calling, I think, like a homogeneous map. But the idea being, if you know the indices of given units, then we can define like a value for each of them, and then just surject those onto the mesh. So if you've got a geologic sketch or whatever, and there are 2 zones, then we can just invert for the values of those.
Mm-hmm.
Then I also went through, and there's examples. Well, there's code now for inverting for electric fields and current density from time domain, just the HJ. Sorry, there's 2 things that I'm talking about right now. Sorry, I went to the DC code, and I added the ability to invert for electric field data. And then on the time domain side of things, there's the addition of a grounded source where we also solve the MMR problem. So if we have, if we've got a permeable object in a time domain problem, we can handle that. So it's like not the best implementation. There's some things like in terms of storing matrices and stuff like that needs to be cleaned up. But at this point in time, like I think it's good enough to include, and then we can refactor. So, because I think it'll make more sense to refactor it with the simulation class in mind anyways.
Yeah.
Yeah, so that is the biggest changes there. So I can bring that in today, and we'll bump to like a patch version, because there's nothing backwards incompatible that I'm breaking here.
Yeah, no, that looks good to go.
Cool. Right now, unfortunately, I did not include examples with the DC, but I'll include links to some of the stuff in my thesis that uses it. So at least if somebody wants to like test it out, you can.
Okay. So is that going to be hard to? Is that stuff from your thesis going to be hard to bring into SimPEG, because that there is a lot of your own code in it? Is that the problem?
There is a fair bit of my own code. It's also like a very niche example. And so like at this point, I don't actually think it necessarily makes sense to like go through the effort of bringing it into SimPEG, because and like that's a little more tractable to people. Or like the notebooks themselves that are included as a part of my thesis should be clear enough that like linking to them is fine. So yeah. Okay, so the next item, just like trying to keep track of SimPEG, and especially if we do this large refactor with the simulation class, like how much stuff do we have to try and rebase and like get onto it? So there's like a lot of branches of SimPEG right now.
Yeah.
There's 41, and so my request is just that everyone go on to yours, and like I've got stuff that is, well, I tried to go through and delete everything that I haven't touched in over 2 years. And so if people could just go in and delete their branches that are stale or no longer being used, that would be super helpful.
Okay.
Yeah, because then, I mean, because there's a lot of stuff that like hasn't been updated in 3-4 years. Cool. Okay, then the last item that I have is there's this conference in Montreal that's coming up. IUGG, I don't actually remember what that stands for. Oh, International Union of Geodesy and Geophysics. So I think Dom is going to submit something on MPI. I'm going to submit something on casings. So if there's anybody else interested in submitting stuff, I'm happy to help, like with abstract writing, editing, all of that. Because I think this is just an interesting one to go to.
Yeah, they have a session on new technologies for mining exploration, so I might submit to that with a petrophysical example. I have to think which example I want to do.
Yeah.
But like I would like to do a new example, but that's an example I would not have started yet. So, but I mean, the code is there, so it's just like, okay, find the data sets I think is good enough for that, and I can publish.
Yeah.
So I'm giving some thought about that, but yeah, like yeah, I think the important information here I want to give is that there is a session, like I think it's A20, which is for new technology in mining exploration, something like that.
Cool. Yeah. Well, abstract.
Sorry, go ahead.
No, go for it, Thibaut.
I was gonna say also the abstract are fairly short, in like 250 words.
Yeah, that's exactly what I was gonna say. It's nothing. It's like similar to like AGU style, and they're due February 18th. So if we can maybe get drafts of them by early next week, that would be awesome. Cool. Guys, no. Okay. Yeah, thanks, no problem. Yeah, so that's all the items that I had on my list. Are there other things that you both would like to bring up, chat about?
I've been all about writing the last few weeks, so
Fair enough.
It's been fairly focused on my own things.
Fair enough. So how's it all going?
I'm getting there. Like I'm running out things with Doug. Like we had a discussion, so hopefully, maybe we were aiming like maybe try to have something by the end of that week. But I feel that we had big questions still hanging around yesterday. So maybe in the end of next week.
Yeah.
I mean, all the simulation is there, so most of the text is there, but we have still some justification to give or slight improvement or stuff like that. But it's all there. It's like it's ironing out the details takes a very long time.
Fair enough. Good. Yeah, and Mike, how are things going on your end?
They're coming. Yeah, not quickly, but they're coming. We're making headway, I think. So
that's good.
Yeah, just to figure out, like, most of the pieces are there. It's just making sure that the storyline is in good shape and you're given enough justification as to why you're doing certain things. So it'll get better.
Good. Cool.
I might steal your computer once I'm done with writing. We'll spend some time, maybe make a shift. I feel yours was more recent than the one I have right now.
Oh yeah, for sure. We might need to get Charles to help out because I just had Linux installed, and then I was hacking around with it and broke the login. So he might need to help, but it is a good computer, so for sure.
Yeah, I was thinking to take my hard drive and to get it plugged in your tower, so it's like super easy. So I don't lose anything of my things. I don't have to reinstall anything. It's just like everything, all the hardware around the hard drive change, but everything stays the same otherwise.
Yeah. Go for it. Cool.
But once I'm done.
Fair enough. And there are new people at UBC. There's an Iranian professor who's visiting.
Yeah, Vaid, he started yesterday. I think he's still getting things ready, like getting his key and access to internet. he might take over Sogi's computer that he has to check with Charles for that too.
Yeah.
That type of things. Mostly Grav and Mag. And I think he's really interested into like also like all those, like we were talking this morning, and he has a couple of papers of like total variation regularization for Grav and Mag, that type of stuff. So he might have a lot of things to talk with them for that, for sparse, on how to do sparse inversion.
Nice. That's exciting. Cool. All right. Well, I will see you both next week. Have a good afternoon.
Bye, Lizzie. Thanks again.